Hello guys. Good afternoon. Good afternoon. Hello. Hi. Oh, Kevin call Kahim. Long time no see. Okay. Not bad, not bad. Long time no see, yeah. Kevin, just now you in U10 class, ah? Haven't touched me. Wait. How busy are you today actually? Okay lah. I have 6 hour class today. Not really. Okay, so since some of you from U10 classes now, so probably you all actually which question U10 stop? Because I don't know whether we're doing the same question or not. Okay. But what I did in the past two classes, question 28. Let me see. What page? Page 33. Wow, so he finished until the page 80. Wow, he very fast, because he never write, is it? he just discuss, show answer, discuss, show answer. Ah, confirm, confirm. Yeah. Okay, so I were at, let me see, let me share my screen. Okay, are you busy tomorrow? You're gonna ask a lot of questions. Can ask lah. But I need to, I will reply you whenever I'm free. Don't worry. You just drop me a message. Okay, so guys, I actually stopped at page number 27 just now. Okay, U10 is slightly faster than me. He's like 5 page faster than me. Okay, so I'm just gonna continue on this question. Okay, before I start, you all see my cat sleeping on my table again. Hello, hello. You see my cat got eyebrow. Hello. Okay. Okay, so what happened we have right now here is we are actually on page number 28. Okay, so don't bite me. Okay, so let me see. Okay, so as we actually do halfway just now, we actually do a lot of voltaic cell, electrolytic cell. Okay, so all these cells, right now we are on the combining questions. Okay, we are combining all the type of cells we actually have in our two topics here. So once again, I'm just gonna continue on here. Okay, we actually have page number 28. It's actually the two cells that we actually have from here. Okay, so we have cell 1 and cell 2 combining together lah. Okay, so we have zinc electrode from the left, then copper, and then got W and X. Okay, but W and X they stated is carbon electrode. You see that? So from what I mentioned just now, for this type of cell, right? These are actually combination of two types of cells that we actually learned before. One is electrolytic cell, one is voltaic cell. So on this case, what we're gonna do, I told you guys, is to actually first find out what cell, which cell is actually which type of cell first. Okay, so one of it must be voltaic, one of it must be electrolytic. Okay, so the first thing first, you see, I told you before, like voltaic cell got what properties, got what special characteristic. Okay, number one, voltaic cell, no battery. Okay, so you see from the first thing here, there are no battery inside this cell here. So number two, voltaic cell usually have two different type of electrode. Okay, you see, got two different type of electrode. So now these two different type of electrode, how are you gonna do? You see from here. If you check all the electrodes from here, we got zinc, we got copper, we got W and X, which is actually carbon electrode. Okay, so what we actually see from here, teacher, which notes? Vinisha, we are on part 1. Okay, part 1. Did you go for U10's class just now? No, hiya. Why you never go to his class? We actually organized 6 hour class already. You didn't know God, Oh no, you never checked Google Classroom, is it? Oh, but even Chloe told know that we have class in the morning. She never told you guys. Oh, it's all Chloe's fault. Blame her. Blame her. Okay. Okay. So what we actually gonna continue from here is we got your page number 28, book one, the book part one. Okay, because we got part one, we got part two, again, and then got part three. Okay. So on this case is here, we have your zinc, we have copper, we have W and X. Okay. So with these two of cells here, okay, first thing first, you see cell one got zinc and copper. So do you see that it fulfills my requirement for my voltaic cell? So I told you before, voltaic cell, number one, no battery. Number two, will be having two different type of electrode. Okay, so when you have two different type of electrode, zinc and copper, this will be our voltaic cell. So this will be voltaic cell. Okay, and then I mentioned to you guys before, voltaic cell can act as a battery for your cell two. Okay, because we know that voltaic cell, it's a cell that generates electricity. Okay, you can produce electron flow from voltaic cell. So voltaic cell right now actually act as a battery for your cell two. That's why you see cell two, even though cell two is both carbon electrode, but it's fine. Because carbon electrode, it fulfills the requirement of electrolytic cell. Okay, electrolytic cell. So we know one side voltaic, one side electrolytic. Okay, so how are we gonna start? Okay, every time we start with all the equations they give you, see this is how they're gonna give you an exam. They're gonna give you some a part, okay, a small part of your SEPS table. Then you actually use that to actually do your question. Okay, let's say for here we have two things on the voltaic cell. One is actually zinc, one is actually copper. Correct. So this zinc and copper from here. Okay, how do we go like? You see, so first thing we find zinc. Okay, where is zinc? Zinc is here, and then copper is here. Okay, but guys, if you go like that, be careful. You know why? Because they might not arrange your series in the correct arrangement. So how to arrange them in the correct arrangement? Is here, we got all the negative 0.76, positive 1.36. So what you guys are going to do first is to actually rearrange everything. Jiahern. Okay. Hi, Jiahern. Which one is this? This one is book part one. Okay, book part one, and then page number 28. Okay, okay. So as I mentioned just now, for this type of cell, okay, before you start choosing, you must first actually rearrange all your equations from here. So I told you before, the arrangement of equation must be from the lowest E0 value, okay, to the largest E0 value. So from top to bottom, low to high. Okay. So who is the lowest E0 value? Obviously, in the whole table here, only got one negative value lah. Okay. So this one negative value will be staying on top. Okay. So this guy is still number one. Okay. Followed by the next smaller number. So if you check, okay, the rest is all positive, except for the H. So this is number 2. Okay. And then got number 3, number 4, number 5, number 6. Like that. So we rearrange them first lah. Okay. So if you rearrange them, you're supposed to get something like this: zinc, hydrogen, copper, and then got what? Got OH minus, got Cl minus, got SO4 2 minus. So I rearrange them in this way first. So even with the rearrangement, okay, after we rearrange everything here, you realize that we actually gonna have your zinc and copper. Because here is zinc and copper. So my question here was supposed to be zinc and copper electrode. So with these two electrodes here, I told you before, you see on now all the chemicals are actually on the right hand side. According to our 6-pack table, guys, what's our 6-pack table? So from the 6-pack table here is here, we have OA, we have RA, weak, strong, strong, weak. So because they are all on the right hand side, okay, right hand side is what? Right hand side is actually our reducing agent. So to have reaction, you must choose the stronger reducing agent. So between zinc and copper, who is your strong reducing agent? Obviously, it's the higher one. So between zinc and copper, I will choose a stronger reducing agent. So it's supposed to be the one on the top, which is the zinc. Okay. So of course, now your zinc gonna donate electron to your copper. Okay, so something like this. So of course, the whole flow will be zinc donate electron, okay, to the other side, and then electron come back and enters your copper. Okay. So from here, we just did a very brief discussion. Okay, so you know, zinc will donate electron, okay, to the right hand side. Then the electron is supposed to go in a complete circuit and then come back through your salt bridge. So you see, do you see a complete cycle? So you go in like this, okay, you donate electron, and then you will come in back like this. Okay, so this will be a complete circuit lah. Okay, so make sure you have one side donate electron, one side gain electron. Okay, so of course this is only for voltaic cell. So how about the cell on the other side, the cell 2? So I told you before, once we actually decide all these things, you have to label your terminal, label your anode, label your cathode. Everything must label very clearly. Okay, so to label this thing up, you see, if you continue on here, okay, we have zinc, okay, and then got copper. Who is positive terminal? Who is negative terminal? I told you guys, the shortcut is look at the side of the voltage. So zinc is negative, copper is positive. So follow this. So zinc is negative terminal. Your copper is positive terminal. Okay, can but then guys, this now I mentioned this in my previous class. Okay, teacher, you give wrong link in Google Classroom. I wait for you at YouTube. Nani? 10 minutes already, no live? No, I thought I started my live already. Nani? My life is different video. I thought I linked to the YouTube already. Wait, but Chu, you at my Google Classroom, why not you just join using my details inside the Google Classroom? Hiya. Ayo, you ni orang Hiya. Okay, never mind, faster. Book one, page number 28. Okay, book one, page number 28. Teacher, can I request video? Can. Go YouTube and watch. Or for 10 a.m. one, or 10 a.m. can. You WhatsApp me later, I send you the link. Okay. Can Okay. So you also want, then come lah, ask me lah. You ask, then I give you lor. Okay. So back to you guys. Just like I say here, if here left side zinc is negative, your copper is positive. So what happened? You want Yutian? Yutian, the one you go ask Yutian. I don't have Yutian video. Okay. So what we actually have from here is negative terminal and positive terminal. Okay. So this terminal from here, we have W and X array. So now on the other side, W and X, who is positive, who is negative? As I mentioned in the previous class in the morning, okay, if it's electrolytic cell, okay, electrolytic cell, the terminal must actually depend on what? Must actually depend on the terminal of battery. So you see, W is connected to the positive terminal of the battery, because guys, I told you voltaic cell is the battery of your electrolytic cell, right? So from here, W is connected to the battery that is positive terminal, means your W will also be positive terminal. Then your X is actually connected to the negative terminal of the battery, then your X is also negative terminal. Okay. So guys, terminal must follow battery. So the battery for electrolytic cell is supposed to be the voltaic cell. Okay, he acts as a battery. So this whole thing, imagine this whole thing is a battery that power up your electrolytic cell to allow for reaction. Okay. Once you have your terminal, remember I told you before, these two different cells got the anode and cathode is different label. Okay. Voltaic cell is A minus. Okay. Electrolytic cell is A plus. Okay. So what happens is cathode is the balik. Okay. So make sure your electron is flowing from anode to cathode and then anode back to cathode. Okay, so like that only can consider a complete cycle. If you realize your electron is flowing from anode to anode, then wrong. Cathode to cathode, also wrong. So electron must always flow from anode to cathode, only you can get a complete cycle. Okay, so in this way, so of course, from here you see, state the function of salt bridge in cell 1 and then identify the negative terminal. So guys, I think salt bridge, we know what's the function. Okay, salt bridge at here is to actually complete the circuit. So I think this one very simple. So complete electric circuit by allowing ions to pass through Okay, and who is the negative terminal in cell 1? So negative terminal in cell 1 supposed to be zinc. So negative terminal in cell 1 is zinc. But they say explain why. So actually very simple. Why is it negative terminal? You can say multiple answers. You can say that he undergoes what reaction, whether he lose or gain electron and stuff. Okay. So we can say because zinc loses electron. So one of the easiest answer, you say he loses electron, then it will be a negative terminal for your voltaic cell. Okay, and moving on, explain the reaction occur in W and X based on movement of ions to each electrode, choice of ions to be oxidized and reduced, half equation at each electrode, observation at each electrode. Okay, so technically, if you move on with this, so what is cell 2 doing? W and X, he is actually doing a simple electrolysis. Okay, but we can actually look at the solution first. What is the solution we have for cell 2? So in cell 2, we suppose we actually have copper 2 chloride solution and CuCl2 is your choice. Okay, but then in CuCl2, what ion inside? So CuCl2 supposed to have Cu2 plus, Cl minus, H plus, and OH minus. Okay, then why got H plus, OH minus? Because solution means got water. Got water means got H plus and OH minus. Okay, so after knowing these two ions, do you remember we have two positive ions and two negative ions? Later you have to choose correctly. And the hint is what? The hint is, do you see this is 1.0? Guys, 1.0 is considered dilute or concentrated. So I believe you all kind of know what's happening. So 1.0 is actually considered concentrated. Okay, consider concentrated. Okay, if it's actually considered concentrated, then later on we're gonna apply the concentrated factor. Okay. So what happened here? Okay, let's say they say movement of ions to each electron. So what we know? So if the movement of ion usually is following the name. So positive ion usually called cation. Cation ion will move to cathode, then anion will move to anode. Okay, like that. So we can say the two ions we have is Cu2 plus and H plus. So the first thing first, so we can say Cu2 plus and H plus are attracted to electrode, to the cathode, which is electrode X. Okay, but then we choose who? We choose the Cu or we choose the H plus. Very simple. Since it's a selection between these two, you go to your series, you go to the table. Okay, you see Cu supposed to be here and here. So what we actually check from here, Cu supposed to be the lower one. Okay, because we are technically taking this and this. But the one in the table is not arranged accordingly. This one is the wrong arrangement. Because H supposed to be higher, Cu2 plus supposed to be lower. So according to our 6 facts table, I'll choose the strong oxidizing agent, which is our Cu2 plus. Okay, so that's why from here we actually selected Cu2 plus is selected to discharge. Okay, but why? What's the explanation? Because they say state the reason why you choose Cu2 plus. So we choose Cu2 plus because Cu2 plus is a stronger agent. But I mentioned stronger agent, there is another way to explain it, is depending on the E0 value. So you see, E0 value of Cu2 plus is bigger, H plus is lesser. So if you selected Cu2 plus because of the positive 0.34, you say that E0 value of copper is bigger value, we call it more positive than E0 value of hydrogen. So you selected this because he's a strong agent, he has a bigger value, so more positive. Even Liang Jie waiting for my life. Is it? Oh no. Why? I linked to this channel already. Why he started a different live stream? Never mind, never mind. I delete this video, okay? I delete this one. My YouTube not this. Yeah, I link already. I don't know why is it not like that. Never mind. I just delete the one that I schedule. I can't even find the one I schedule in YouTube. Yeah. I don't care lah. Not a YouTuber, man. Okay, moving on, guys. So after explaining the E0 value is more positive, we're gonna write half equation, we're gonna write the observation, okay? So what's the half equation after you selected Cu2 plus? So you see, guys, I told you before, if you select this one, you just go along with the flow. If you selected the other side, you go backwards like that. So the equation is actually no need to memorize one. You just take what you selected and then just go with the flow. So what we selected here is Cu2 plus. So you go with the flow, plus 2E minus, you form Cu. Okay, can Then moving on, okay, observation. Guys, if you form a copper metal, what is the color of a copper metal? So I believe you all know just now I said it, copper metal is the metal you all have in your phone cable. What you can do, take a scissors, cut the phone cable, you will see what is inside. So from here you can see brown solid form at electrode X. Okay, so this is on the copper side, guys. This is on the electrode X side. So how about the other side? On the W. W is who go to W? Is the anode. So means N ions will actually move to anode. So you'll be having two selection. Again, Cl minus and OH minus. You're gonna choose one. Okay. So in this case, we say Cl minus and OH minus are attracted to electrode W. Okay. So if you actually go to the electrode W, you're gonna choose one now. Guys. Usually, just now on the cathode, I choose the stronger agent. Okay, explaining by talking about the E0 value, right? But guys, if you remember, just now we discussed, if it's a concentrated solution, remember in our factor just now, if it's concentrated, okay, at the anode, this is your notes that given to you guys. At anode, if it's concentrated, you'll be selecting halide ions, which is a Br minus, Cr minus, Br minus, I minus. If no halide, then only you proceed to go back to the previous factor by choosing the stronger agent. But right now, in your selection, we actually have Cl minus, which is our halide ions. So because of the halide ions is there, so we're going to choose it. If no halide, then you still proceed for the stronger agent. Okay, so the problem right now, you've got halide. Okay, so you must choose the halide. So we can say chloride ion, Cl minus, is selected to discharge. Okay, so what happened to the Cl minus? You can say that, okay, they say why you choose Cl minus? Because it's concentrated. So we can say that concentration Higher concentration, yes, correct. So concentration of chloride ion is higher than hydroxide ion. Okay, so because it's concentrated, we selected already. Next one will be equation. So equation will be Cl minus. Okay, you're gonna actually go with the flow, guys. What was the trick just now? Is Cl minus is here, ma. So if you selected Cl minus, you go backwards. If you selected left side, you go right side. If you selected right side, you go left side. So just copy paste this equation, but in an opposite way. So Cl minus becomes Cl2 plus 2 electron, valence equation. Okay, so this is the half equation. And what you're supposed to see? What's your observation? Guys, what's the color of chlorine water? So we can say, okay, from here, okay, for electrolysis, right? Usually you will form chlorine gas. Okay, so the chlorine gas supposed to be something like yellow gas. Okay, greenish yellow gas also can. So your four answers should be greenish yellow gas is released at electrode W. Okay, so guys, hopefully you guys have a better idea. So moving on, we have the potassium manganate 7, which is also our oxidizing agent again. But right now we actually put into and react with our metal powder. So this is to investigate the reactivity of metals towards oxygen to form metal oxide. So means what? When I heat manganate 7 powder, it's supposed to release oxygen gas. Okay, so when oxygen gas is released, and then you actually flow it through a hot metal. When it's actually a hot metal, it will react with oxygen, and then it's supposed to give you some reactivity lah. Okay, you get big fire, small fire, explosion, this or that. So when iron is heated using the apparatus, okay, when iron is heated using the apparatus shown, iron 3 oxide is formed. State the color of iron 3 oxide formed and write a chemical equation for the reaction. And then calculate. Okay, so there's a few things to do here, guys. First of all, what's the color of iron 3 oxide? So what's iron 3 oxide? Iron 3 is supposed to be Fe 3 plus. Oxide is O2 minus, so supposed to be Fe2O3. Okay, so as you learned this out, we learned before, we always turn Fe2 to Fe3, Fe3 back to Fe2. So Fe3 what color? Fe3 is actually brown color. Okay, and then write a chemical equation. So we started off from Fe, pure metal, because they say it's metal powder, plus oxygen. You react to form Fe2O3. So you're gonna balance your equation. Okay, so this one you're supposed to get 1 mark. This one you get 2 mark. Right and balance, you get 2 mark. Okay, then after that, calculate your mass of metal oxide when 14 gram of iron is heated. So what we actually have is 14 gram mass is 14 gram. You have this, but they want you to actually calculate the mass of metal oxide. Okay, so how do we do this calculation, guys? Just now, Dylan, you also asked me about this question, right? So this is a similar concept. So if you learn this already, later you do it later on in the question. Yeah. So at here, you have the mass for Fe, but you want to find the mass of Fe2O3. How to know all these things? Because first of all, they mentioned calculate mass of metal oxide when you have 14 gram of iron. So you have to know what are all the information provided and then what you're trying to find. Once everything is actually labeled down already, we can start from step 1. Step 1, guys, since I got mass, how do I relate from Fe to Fe2O3? The only common thing between chemicals is number of mole. So what we can do, since we have mass, we take mass formula. What's mass formula? Number of mole equals to mass over molar mass. Okay, so wait. Okay, so number of mole here we take, okay, but here, since we have the mass of Fe, we're going to use molar mass of Fe to find number of mole of Fe. Okay, I need to label down everything very clearly from here. So we have mass of Fe. So mass is 14. Okay, but what's the molar mass of Fe? It will be 56. Where I get the question? Okay, so guys, take your calculator. 14 over 56. What do you get? Is it 0.25? I guess so. This is a quarter of 56. So if you press the calculator, come guys, what do you get? 0.25, correct? Okay. So 0.25 gram. Sorry, this is number of mole. Mole. Yeah, okay. But to actually move on to Fe2O3, you can't use this 0.25 from here 0.25 will actually go and actually move into Fe2O3 ma. Okay, so on this case here, what we actually go from here is number 2. Before I go for Fe2O3, you must actually compare ratio. How to compare ratio? Okay, guys, the pink color one is no mark one. So you compare between Fe to Fe2O3. How to compare ratio? Look at the balance number. So in front of Fe got 4. In front got Fe2O3 got 2. So means the ratio is 4 to 2. Okay. 4 to 2. So means if it's 0.25, what is the value for this? Then that will be the number of mole of Fe2O3. So ratio 4 to 2 means it divides 2, right? So means this Fe2O3 also divide 2, we'll get 0.0125. Okay. Can I, guys? Can I? So the problem is writing this ratio don't get marked. You're gonna write in sentence. Okay. How to get marks? You can say 4 mole of Fe produces 2 mole of Fe2O3. Okay. And then 0.25 mole of Fe produces 0.125 mole of Fe2O3. Like that, only can get 1 mark. Okay, so the concept behind is supposed to be ratio lah. Okay, supposed to be ratio having here. Okay, and then later on we actually gonna go for step 3 lah. Okay, so why? Because like this only consider your number of mole of Fe2O3. Because if you want to find the mass of Fe2O3, you need the number of mole of Fe2O3. So therefore, number of mole of Fe2O3 equals to mass of Fe2O3 over the molar mass of Fe2O3. So since we have here already, so 0.125 put inside here. So you'll get 0.125 equals to mass of Fe2O3. Okay, but guys, what is the molar mass of Fe2O3? So guys, when you calculate molar mass, don't times the 4, don't times the 2. That balance equation only used for compare ratio. Okay, the 4 and 2 only for compare ratio, not involved in your calculation. Okay, so I say from here, molar mass of Fe2O3, so you do it yourself lah. Okay, so it'll be Fe2 will be 56 times 2. O3 is 16 times 3 lah. So for your final answer, mass of Fe2O3, you get the number at the bottom, bring over, multiply the 0.125, you get your mass of Fe2O3. Okay, so guys, give me the answer for this. Okay, 20 gram. Correct. I don't know, I know answer. Teacher, is your lesson same with U10 class at 10 a.m.? We doing the same material. But I think his 10 a.m. class only managed to do until page number 33. So I haven't reached there lah, but my aim is to finish the whole page, the whole book until page number 38. Discuss same question. He do until 33 ma. So I will do the whole thing. So he will also discuss this question lah. Okay, then electrical energy can be produced by redox reaction. You are supplied with a lemon, a piece of zinc, iron nail, connecting wires, and a bulb to build a chemical cell to prove the above statement. Okay, draw a label diagram. So guys, first you have lemon. Obviously, lemon juice is your electrolyte, no? Your salt bridge again. Then you got zinc, you got iron nail, your two different electrons, and connecting wires to a bulb. So I think this one you can basically picture your diagram already. So guys, let's try to draw together. Let's say we have a lemon. Lemon how to draw? Okay, lemon like that. So ugly. But never mind, guys. Lemon. Looks like mango. Hey. Okay. Wow, you all judge my lemon. Come. Okay, guys. Okay, I give up. Like that. Wait, no. Lemon. Like that, okay. Okay. Baby face with ear. No. So, like, okay. So, of course, shit, I can't unsee what I draw. Hey, you are. Okay, so we're gonna put in your zinc, put in your iron. So we're gonna put in your zinc. Okay, zinc like that. Okay, and then iron nail like that. Okay, and then got connecting wire with onto a block. Okay, yeah, okay, understand. Okay, here now got what? A baby with an antenna. Okay, label everything. Okay, this is iron nail. This is bulb. This is connecting wires. And then this will be zinc. UFO. If I terbalik zinc and iron nail can. Doesn't matter. Because if you terbalik, it's basically just different flow of electron. Okay, and then they say draw already, draw the arrow to show the direction of electron flow. So basically, guys, how electron flow? Zinc to iron nail or iron nail to zinc. So this one actually very simple. Just find whoever that donates electron, whoever that gains electron. Okay. So zinc and iron nail, actually, who is actually more reactive? The one that we remember last time in the reactivity series, or even you can just refer back to the table. Do they have Fe or don't have? Okay. So technically, the one that is more reactive will donate electron, which is zinc. So zinc will donate electron to your iron nail. Like that. So the red color is the direction of electron flow, the arrow. And then write a suitable half equation and ionic equation. So for both sides, okay, let's say for the, okay, we got two reactions here. One is oxidation and then one is reduction. Okay, so who undergo oxidation? Supposed to be the zinc. So Zn oxidized becomes Zn2 plus 2 electron. Okay, but then when the electron being donated to the iron nail will receive the electron. The thing is, when iron nail receives electron, the equation is not on the iron nail. Just like last time when we do our redox reaction on this cell here, this is how you see. Do you see our equation is on the solution who gain electron? Like you see, even we say the copper copper will gain electron, but the equation is not on copper. Because what we do on the metal usually is just there to conduct electricity, just to take in the electron. But who is actually the guy that gain the electron to form a reaction will be the solution. Will be the lemon. So you know, lemon is actually acid. And acid, all acid got what ion? Someone asked, how do you know electron flow from zinc to iron? Because zinc is more reactive, iron is less reactive. About the reactivity, you can refer to the notes we have in our notes in the front. Yeah, you can either refer to this table, or you can refer to the electrochemical series that we have in our book. That is page number 34. Okay, do you see zinc is more reactive than iron? So if it's more reactive, then he will donate electron. The more reactive one will donate electron. Or you can also refer to the SEPS table, the one I mentioned just now. This table, do you see zinc again is showing you more reactive than Fe? So it's always the more reactive guy who donate electron to the less reactive element. Okay, so from here, we come back to here. Supposed to give the electron to the lemon. So as I said, lemon is acid. What is the ion that all acid got? All acid got H plus. So this H plus will gain the electron to form H2. So balance equation, you get this. Okay, so it's the zinc who donate electron, and the iron will gain the electron and pass it to the lemon. Okay, that's why when we do voltaic cell, it's always one side corrode, one side dissolve, the other side nothing happened. The solution something happened. Okay, so iron nail is technically here doing nothing, just to conduct electricity. Okay, this is the half equation and ionic equation. Okay, guys, how to write ionic equation? I mentioned this. Combine them together by having the same electron number, cancel them off. So since here already got 2e and 2e, there's no need to do any balancing. Just straight away cancel this. Whatever before arrow, put together. Whatever after arrow, also put together. So at here, supposed to be ionic equation will be zinc plus 2H plus. You form Zn2 plus H2. Okay, so done with ionic, we're gonna go for the suggest a suitable oxidizing agent and the suitable reducing agent. So, as according to our oxidation and reduction, who undergo oxidation, who undergo reduction, will be an opposite agent name. So ionic equation have plus and minus, right? Yeah. Only ionic equation got plus and minus. Half equation also got, but half equation got one extra thing, is the electron. Okay, ionic equation only got ion and the element and the molecule, but no electron. Chemical equation is no ion at all, no charge. So we got chemical equation, we got ionic equation, we got half equation, three different types. Okay, so we know this guy, he undergo oxidation, so we call him the reducing agent. And then this guy undergo reduction, we call him the oxidizing agent. Okay, guys, exam do write like this. Okay, exam, you put in like oxidizing agent is hydrogen ion. Then your reducing agent is zinc. Okay, so of course, moving on, we actually have your last question of our cells from here. So after this later on, I think is chapter 2. So that one will be our last topic lah. Okay. So right here, guys, we actually do the last question for here. We have W, X, Y, and Z against cell 1 and cell 2. So hopefully you guys, after so many questions, you can start by finding out your voltaic cell first. So who's your voltaic cell? If you see cell 1, cell 2, which one do you think is actually more suitable to be a voltaic cell? So from here, we find the one with the 2 different electrons, correct? Cell 1. So cell 1, okay, cell 1 got zinc and copper ma. See, same. Okay, so this one is voltaic. So this one is electrolytic. Okay. Then what we're gonna do? Okay, since we know got zinc and copper ma. So you see, they actually give you arrow. Zinc donate electron. Means if they ask you to draw this one, you're supposed to go backward because you're going to form a cycle. Okay, you're going to form a complete circuit. So if I put it like this, I aim myself because we know. So put it like this, everything like this. Let's try, see whether what you can do. So first of all, what is the meaning of redox reaction? And then what is the type of cell for cell 1 and cell 2? So guys, what is redox reaction? Redox reaction definition, very simple. Redox reaction means that oxidation, reduction occurring at the same time, or you can say occurring simultaneously. Okay, so from here we can say reaction that involves oxidation and reduction that occurs simultaneously. Okay, then cell 1, cell 2, we just found the answer ma. So we can say cell 1 is voltaic cell, and then cell 2 is electrolytic cell. Okay, easy 3 mark. Okay, then moving on, they say write the cell notation and calculate cell voltage given with the standard electropotential value at the bottom here. So guys, from here, you see this is actually the slash is basically BM version. After the slash is English version. Okay, don't get confused. Okay, do you see got AK, got P? Because and you know the SVM is supposed to be dual language. Okay, so we only look at the English version, the AQ and the S. Okay, AK is aqueous, P is purple gel, solid. Okay, so of course, we only look at the first one, and the second one, of course, we just ignore this one. This one ignore. Okay, so are they arranged in the correct arrangement? So yes, it's actually from negative to positive. That's correct. How to write cell notation? Guys, I gave you a shortcut on cell notation is what? Cell notation is starting from the top right. 1, 2, 3, 4. Like that. Go anti-clockwise. Okay, go anti-clockwise like that. Okay, and then you actually write equations about it. So we can say not equation, guys, right? What is the changes? What happened after that? So zinc supposed to be a solid, okay? Then after that, he turned into what? Into zinc 2 plus, which is an aqueous. So we actually put a 1 slash like that. Zinc 2 plus, which is an aqueous. Okay, but I told you, if the question will give you molarity, will give you concentration, you must put it in. But like right here, the question never give you anything. Just close the bracket, okay? Because after the bracket, it will be moving on to Cu2 plus, right? So now if you change chemical means you actually go over the salt bridge. So you're supposed to having a double line here to indicate salt bridge to the next chemical, Cu2 plus AQ, last line, okay, Cu solid. So that will be a cell notation. And how to calculate your cell voltage is your big number, big voltage minus small voltage. So big voltage 0.34 minus negative 7.06. So negative become positive. You're supposed to get 1 point something like that. 1.1. It's a 1.1. I think, yeah. Okay, so you're supposed to get 1.10. Don't forget 2 decimal place, because they give you 2 decimal place. You follow 2 decimal place, 1.10 volt, and don't forget it's a positive sign. Never put sign less 1 mark. Will they give us the AQ and solid? Yes, usually if they give you the SEPS, okay, the electric potential, then they're supposed to give you the voltage and also the physical state. Okay, moving on. Which substance will undergo reduction reaction? So from what we learned just now, okay, zinc to zinc 2 plus, oxidation. Then Cu2 plus to Cu is reduction. How to check? The charge increase, decrease lah. So reduction is charge decrease. So charge decrease, reduction. So we can say it's the Cu2 plus. So copper to ion, and why? We can say copper to ion, he actually gain electron, or you can say decrease in oxidation number. Also can. Copper to ion gain electron to form copper atom. Okay, then based on cell 2, identify the positive terminal and negative terminal. Okay, guys, this one what we learned just now. Okay, since we know zinc from here, okay, how to know who is positive, who is negative? Let here, zinc is negative, copper is positive. So since here is negative, here is positive, and then your cell 2 follow the voltaic cell because cell 2 is electrolytic. Electrolytic is follow the battery. So Y supposed to be positive terminal, Z supposed to be negative terminal. Okay, and what we supposed to actually continue from here? Okay, let's say we do a simple brainstorm here. Copper 2 sulfate is CuSO4. Then inside got Cu2 plus, SO4 2 minus, and then got H plus and OH minus. Okay, so the positive ion will move to Z, the negative ion will move to Y. Okay, but who do we choose? Okay, so at here, we will choose according to the agent. Okay, so what was the agent just now? Okay, I told you to choose a strong agent. Okay, from here, we actually will choose, or they never give you. They're supposed to give you this one, but never mind. As I mentioned, if it's dilute, okay, for the negative ion, always choose OH because OH is supposed to be the strongest reducing agent among all the negative ion. So if it's not concentrated and if it don't have halide, no halide, straight away choose OH. Okay, so that's the first thing we know. Okay, and then for the positive one, choose the stronger one also lah. So stronger one supposed to be Cu2 plus. Why? Because again, according to our SEPS table is here, H plus is here, Cu2 plus is here. So according to the 6-packs table, bottom one is strong oxidizing agent. So we're supposed to choose a Cu2 plus. Okay, so in this case, we can say that who is positive, who is negative? Y is positive, Z is negative. So electrode Y is positive terminal. Then electrode Z is negative terminal. Okay, then after we choose, okay, for At Y, right, we choose the OH. For Z, we choose Cu2 plus. Okay. So from here, I just mark down this myself. Okay. We're gonna select OH minus. We're gonna select Cu2 plus. So guys, what's the observation if you select OH, if you select Cu? So you try to imagine their equation. Cu2 plus is the easy one. Cu2 plus, when you undergo reaction, you lose the charge, become copper metal, supposed to be a brown solid. Then OH, a bit special because OH equation very long. You're supposed to form water and oxygen. So you're supposed to see colorless gas bubble. So we can say, again, for observation, at Y, you will see colorless gas bubbles release, gas bubble form. Okay, then on observation for Z, you will say brown solid form. Okay, guys, so officially done with all the chapter 1 questions for this book. Okay, we're gonna move on to Form 5 chapter 2, your carbon compound. Let's go. Okay, guys, technically it's the last topic we have in this book. So if I can finish this before 6, then I will end this class before 6 lah. But then we have 2 hours, which I still got 2 hours to finish off 8 pages. Hopefully, can hopefully. Can okay. Xi Jian say easy carbon compound. Okay, so guys, as I mentioned, this is our analysis. Okay, according to last year, past year. Okay, this year this thing not really came out in exam. Okay, so we try to do it here so that if come out next week, congratulations. Okay, but then of course, again, guys, we put some special questions here. Each question, wow, Xi Jian lan xi. Okay, Xi Jian, I pass the host to you, you dish. Okay, so now, nice. Okay, it shows a flow chart of the change of an unsaturated hydrocarbon. Okay, the unsaturated hydrocarbon, okay, guys, what is unsaturated? Unsaturated means got what bond? Because we learned before alkane, alkene, alcohol, carboxylic acid, ester. Okay, unsaturated means got double bond, correct? And then you see, unsaturated can become saturated, can also become compound X by adding 2 different things. So name the homologous series. What is homologous series? This one I guarantee a lot of people cannot answer. Correct. Homologous series means like the type of carbon compound, which is the name alkane, alkene, alcohol, carboxylic acid, ester. So that is the name of homologous series. Wait. Okay. So say the name of homologous series and the functional group of the unsaturated hydrocarbon. So guys, since you all told me unsaturated got double bond, then got double bond is considered what homologous series? And it's unsaturated hydrocarbon. So guys, actually in our syllabus, we only got 2 hydrocarbon. First of all, do you know what's hydrocarbon? Hydrocarbon means this chemical only contains hydrogen and carbon. Means anything else inside is not considered hydrocarbon already. So in our syllabus, only got 2 hydrocarbon, which is alkane and alkene. Why? Because alcohol is not, carboxylic acid is not, ester is not. Why? Because these 3 got what? Got oxygen. They got C, got H, correct, but also got oxygen. So if got oxygen inside in the chemical, it's non-hydrocarbon. So that's why I say hydrocarbon only got 2, alkane, alkene. So obviously, with the double bond, we know that this guy here is supposed to be alkene. What carboxylic acid? I say the carboxylic acid inside got oxygen. Okay. So this is supposed to be alkene. 1 mark. Hi, Sijen, you see your friend Ling Yi giving me all the weird answer. Sijen, help me slap her. Okay. When you see her, help me say hi to her with your palm on her face. Okay. So now moving on, the functional group of the unsaturated hydrocarbon. Okay. So now, what is functional group? Means a special group inside all the hydrocarbon, all the homologous series. Okay. Sijen agree. Okay. Sijen, thank you. Thank you. Okay, so what is functional group? Functional group means a special part for all the things we learn. Okay, so let me go back to the notes. Okay, guys, let me see from 5 chapter 2. Okay, so see, homologous series is basically the top. Okay, guys, this is page number 49, just in case if you're looking for the notes. Homologous series is all the name on the top. Okay, then functional group is all the special group of all the top, all the category. So alkane functional group is carbon-carbon single bond. Alkene is carbon-carbon double bond. Alcohol is hydroxyl group. Carboxylic acid is carboxyl group. Ester is carboxylate group. So at here, because we are talking about alkene, so means your answer here is supposed to be carbon-carbon double bond. Okay, then draw the structural formula and state the name of compound X. So guys, X is what? X is taking hydrocarbon plus Br2 ma. Correct. State the name for compound X. Okay, so you add Br2 from here. So guys, what is supposed to call this? Did they mention what is how many carbon? Oh, they say here got 2 carbon. So guys, 2 carbon know how to draw not? 2 carbon like that no? So 1, 2. Okay. So how to draw a normal 2 carbon alkene? Supposed to be ethene ma. So this one is supposed to be a normal alkene supposed to be like this. Okay. But guys, this is not the answer. Why? Because they say draw and state the name of X, which is this. What is your name of your X? I don't care. Come here. Okay. So from here, see so this X here is after add Br2 ma. So what happens if Br2 add into your alkene, into your ethene? So you go in and actually take away one of the bond. So I told you before, guys, the double bond basically the bond is a pair of sharing electron. Means if I take away one bond, okay, open up, you will see one electron here, one electron here. Just now previously it was supposed to be one electron here, then you share to get a bond ma. So now we open up the bond so that your bromine can come in to form a new bond. Bromine can come in to form a new bond. So this is the drawing for the alkene after adding bromine. So what do we call this? It's drawing 1 mark ma. They need the name also. So this is no longer ethene. What do we call this? This is a 2 carbon with single bond. So we call this ethane. But then got bromine ma. So with the bromine, we call it bromo. Okay. And then since you have 2 bromine, you call it dibromo. And then the 2 bromine is one at 1 carbon, the other one at the other carbon ma. So it's 1,2 dibromoethane. Stick together? Yeah, stick together. Wow, susah. Hey, hello. Carbon compound never revise. How Sijian? Very easy. Okay. This chapter give up lah. Hey, this chapter is the easy one. Why give up? Okay. How come got 1,2? Okay, see Okay, the name, first of all, is to look at the overall homologous series. So the homologous series is 2 carbon alkane because it's all single bond. So it's ethane. 2 carbon is eth ma. Alkane is ATE, A and E ma. So ethane, okay? Then got 2 bromine. So 1 bromine is called bromo, 2 bromine called dibromo. Okay, can Then what we happen here is to have what? Is 1, 2. Okay, why got 1, 2? Because if I label down carbon number, this is carbon number 1, this is carbon number 2. So do you see one bromine at carbon number 1, one bromine at carbon number 2? So you will get 1, 2 dibromoethane. Okay. Why must put a number? Because what if I change my position? Maybe I change like this. Can you still call this 1, 2 dibromoethane? No, we call this 1, 1 dibromoethane. Okay. So that's why I have to go back to like this. Okay, this one is 1, 2 dibromoethane. Can okay, so from here, someone asked, why not ethene? Okay, because after adding already, no more double bond. So no more double bond means cannot call ethene anymore. Ethene is because double bond. Okay. Okay, someone on YouTube asking about, teacher, how about alkyne? Okay, alkyne is basically triple bond, but triple bond, very low chance to come in exam. And technically, whatever alkene can do, alkyne also can do. Just that you can do more frequently. Okay, because double bond, triple bond basically is having free bond. You can add whatever you want. You can add hydrogen, you can add water, you can add bromine, you can add chlorine. Basically, alkene and alkyne is just one more extra bond. But whatever reaction they can do is the same. Okay, so of course, moving on, we have both the unsaturated and saturated hydrocarbon can be burned completely in oxygen. Write the chemical equation for the complete combustion of saturated hydrocarbon and determine the hydrocarbon that will produce more soot and explain your answer. So how to write complete combustion, guys? Combustion means burn with what? They actually tell you, burn with oxygen. So we say the two calculation here. Okay, first of all, is both of the saturated and unsaturated. Okay, someone asked what is soot? Soot means the black smoke. Okay, when you burn something, it will come out black smoke. So black smoke usually depend on what? Depend on the percentage of carbon. That's why they ask you to calculate, do some calculation and then try to ask you to see who can produce more soot, is to find the percentage of carbon. Later we're going to do for you guys. Okay, first thing, let's try to write the equation for the saturated hydrocarbon. So saturated is what? Saturated is technically after adding a H2. Okay, so imagine just now was C2H4. Guys, after adding H2, what you form? C2H6. Okay, okay, so the diagram is supposed to be similar to this, guys. Similar to this. Just that just now we have Br2. Now I add H2, I take this away, I put in H and H. So it's C2 and then H6 in total. Okay, so from here, the equation will be C2H6 plus oxygen. Okay, guys, complete combustion have two fixed products. What are the two fixed products for complete combustion? You burn alkane, you burn alkene, you always get two fixed products for complete combustion. Jiahern, not bad. You got the first one correct. One more. Correct, guys. It's actually CO2 and H2O. Okay. So complete combustion, no one going to tell you what you're going to form. You certainly have to know is water and carbon dioxide. Okay. Then, guys, balance equation. Hopefully you all know how to balance equation. So to balance equation, I supposed to put a 2 here. Then I will put a 3 here. So to get C2H6, C2H6. But then you realize that I will get, here got O4, here got O3, plus together is O7. But in the front got O2. One is even number, one is odd number. So even number, odd number, how to do? So there are two ways to do this. There are two different approach. Since at the back got O7, in the front only got O2. So they cannot actually put a whole number to get you a balanced equation. So what you can do is, I can put in a 7/2. Why? Because like that, I can cancel the 2 and 2 away. I get 7O. Then I get like O7, O7. like this also can. Okay, if you don't want to put fraction, okay, because some teachers say no fraction, up to you. You can basically just multiply the whole thing by 2. So see, I put a 2 here. Okay, so I put a 2 here. Then this one I take away. I left with 7 because I multiply whole thing by 2 ma. Then I will get 2 and 3 become 4 and 6. So technically they are the same thing. Okay, just with the whole number and fraction. Okay, some teachers say no fraction, then don't do fraction. Some teachers say can do fraction, just do fraction. SPM both acceptable. Can so after all these things already done already, you get, then which one is better? I will prefer whole number. Because I am a bit OCD. I don't like fraction. Okay. Okay, determine the hydrocarbon that will give you more soot. How to know who is more soot? Calculate percentage of carbon. So got 2 chemical ma. One is one is C2H6, one is C2H4. Okay, how to calculate percentage? So percentage of carbon is equals to, you take, okay, how to find percentage? Just like how I find percentage of my result. Whatever I score over 100, correct? So something like this. How to find mass of carbon is to take mass of carbon over total mass. Something like that. So how many carbon we have in C2H6? So I got 2 ma. So 1 C is 12. 1 H is 1. Okay. So how to do it? It will be 12 times 2 because C2. But over C2H6, over total, guys, total. C2H6 is 12 times 2 plus 6. Then whole thing multiply 100. Okay, so guys, do your maths. Okay, so means it's supposed to be 24 over 30 multiply 100. Okay, press your calculator. Okay, then you do the same thing for C2H4. Is also C2, but then your total mass will be slightly different. It's 12 times 2 plus only 4. Why here plus 4? Because here only got H4. Here got H6. That's why it's H. That's why I plus 6. At the back, this one is only plus 4 because only got H4. So this one is 24 over 28 multiply 100. So guys, come give me the percentage. 24 over 30 multiply 100. What you see? Okay, Dylan is getting 80%. Okay, how about the next one? Okay, Jocelyn also getting 80. That's good also. Dylan getting the next one is 85.71. Okay, did they give you decimal place? Okay, guys, we put 2 decimal place lah. The most accurate one is 2 decimal place, so 80.00. Because here already got decimal place, to match, you must put the same decimal place. So according to this calculation, who give you more black smoke? So black smoke depends on how many percent of your carbon. Higher percent, more carbon, more black smoke. Okay, so the answer here, you can say that percentage of carbon is higher in C2H4. So we can say C2H4 will produce more soot, more black smoke. Okay, then moving on, we have the acidified potassium dichromate 6 and butanol. Then you can say we have a solution L with a water bath inside here, everything here. Then what do you think? They say solution L produced is used in reaction A and reaction B. Behind 100 must put 0.00, must, because you must match how many decimal place for both answer. If the one at the back got 2 decimal place, then you must put 2 decimal place for the front one also. Must be consistent. No drink tea, tea finish already. Now I drink alcohol. No lah, where got drink alcohol one? This one normal water, okay? Eternal time. Okay, so guys, from the next one, it's actually a result in given here. So we have solution L, one is heat, one is no heat, and then concentrated sulfuric acid, and then sodium hydroxide. Okay, now, based on diagram 8.2, state the name of reaction to produce L and identify L. So what is L? Okay, they say L produced is used in A and B. So they say, so technically is what we actually have here is the acidified potassium dichromate and butanol combined react. You're supposed to form solution L. Okay, I'm supposed to form solution L. So what is the type of reaction? Okay, what's happening here? We have butanol, but butanol is alcohol. Alcohol add potassium dichromate 6. You're gonna be like, teacher, why this chapter also got redox reaction? Let's see here. Correct. It's oxidation. Why is this oxidation? Because what agent do we call our potassium dichromate and potassium manganate? We call them oxidizing agent, right? So technically, they will supply oxygen and they will oxidize your butanol. And if you're not sure what's happening right here, if you go back to the notes in our carboxylic acid, just now the flow chart, okay? Do you remember that your ethanol, okay, your alcohol, you can oxidize it to turn it into your carboxylic acid? And how do we do that? By putting oxidizing agent. You see, I can put KMnO4, I can put K2Cl2O7. So I can oxidize it. I can oxidize my alcohol, become carboxylic acid. Okay, you get what's happening here. Huh? So technically, your L, I would say your L is supposed to be carboxylic acid. Okay, carboxylic acid. And according to butanol, I will expect that your L is butanoic acid. Okay, guys, you see, just by looking at this picture, I know L is butanoic acid. Okay, all good. Okay, then we take the butanoic acid, I add into my ethanol and sodium hydroxide. So the first thing in A, you realize that butanoic acid, okay, just now I say it, your L is butanoic acid. Okay, do you think your acid and alcohol, okay, after reaction, do you see he form a special layer? And then acid plus sodium hydroxide, no special layer, okay? But I never tell you what color is it lah. So now, state the name of reaction at A and B, and explain why there's a difference in observation for both reaction and write a chemical equation, 10 marks. Let's look at A first. What reaction do you think this is? I take carboxylic acid plus alcohol. Guys, any idea? Yeah. And if you're not sure, do you remember what is the chemical that will float after produce? Technically, guys, it's your ester, because ester is less dense. And if you don't remember, again, your notes is there to help you. Do you see alcohol plus carboxylic acid? You can do esterification. So you see, the relationship is I can oxidation my alcohol, become carboxylic acid. Then I can take the carboxylic acid, add to my alcohol. Together, you form ester. So that's why this chapter is hard, because you need to know all the clear relationship between all these chemicals here. You can go from one chemical to the other chemical. Then you can take these two chemicals, add together. Okay. So of course, CJ say easy. Yeah, CJ. Until now, okay, not? CJ confirm say easy. Steady pokey. Okay, so yes, guys, A is supposed to be esterification. Okay, then what is B? B is acid plus alkaline. Guys, acid alkaline, what you call it? Easiest thing ever, man. Acid alkaline, neutralization. Okay, you get 2 over 10 already. Okay, next question. Okay, so of course, let's try to list out the name. Okay, they say state the name of L first. Okay, say a reaction to produce L and identify L. Actually, this one also 2 marks. Wow, so good. Actually, we got 4 marks already. Why got 4 marks? So the reaction name to produce L. Just now, guys, I told you what. What do you call the process where your alcohol become carboxylic acid? You oxidize it, so it's oxidation. So here, number 1, you see reaction to produce L is oxidation. Okay, and who is L? L is butanoic acid. 2 marks. Yay. Okay. Once you know your butanoic acid, we say that reaction A is esterification. Then reaction B is neutralization. And now the next 4 marks enough. Wait, janganlah eh. We aim for more. So explain why there's a difference in observation for both reaction. So why got difference in observation then? Okay, so first thing is, for A, you see a layer of ester. And why got layer floating? Because it's less than. So something like this, you can see the observation will be 2 layers are formed in test tube A. Why got 2 layers? Because we know reaction A produces ester which is less dense and float on top of water. Then reaction 2, why no 2 layers? Because acid plus alkaline, you form salt and water. Your salt will dissolve into water. So you don't see 2 layers, only got 1 layer. So 1 layer is formed in test tube B. Why? Because reaction B produces salt and water, where the salt is dissolved in water. And they want the chemical equation for A. It's like, I would say these 10 marks are the hardest marks to get is the equation. What is butanol and butanoic acid formula? So but is how many C? 4C, correct. So butanol supposed to be C4. Then okay, if you want to recall back, supposed to be your general formula. Where's your general formula? For alcohol, CnH2n plus 1 OH. Carboxylic acid, CnH2n plus 1 COOH. But for the COOH, remember the C in the front must reduce by 1. Okay, so from here, butanol supposed to be C4H9OH plus, okay, I give you some hint here, CnH2n plus 1 OH. Okay, then carboxylate is CnH2n plus 1 COOH. Okay, but the question comes in, guys. Butanoic acid, right, is also 4C, right? So do I put my 4C at here? C4? No, reduce by 1. Why? Because at the back already got 1C. So C3H7COOH. Okay, if you put C4, in total you will have C5. Then the one is the next acid already. So to get butanoic acid, must 1 at the back, the rest in the front. Okay. Then how to form ester, guys? To form ester actually is very similar like how you all combine polymer. How you all do esterification? Take out H, take out OH, basically take out water, then you connect everything. So what is connect water? What is take out water? I will take out H and OH. The part that disconnected, combine. So I will write down the butanoic acid first, C3H7CO. Then I will combine with the OC4H9. So do you see this part? Is from here. Okay. And then this part is from here. Okay. And don't forget, you remove water, so H2O. So the good thing about equation for esterification is you don't have to balance equation because you are just taking in, putting out, taking in, putting out. Okay. Overall number don't change. Okay. So guys, you see, 10 marks. So when name compound alcohol in the front, yes, if you draw carboxylic acid in the front, if you name supposed to be alcohol in the front. So let's say if I name this ester, this ester is called what? C4. So it's butyl, and then this is still C4. So butyl butanoate. This one. Okay, so naming for ester is alcohol first, acid later. Teacher, why cannot C7H16? Technically can, but we can. The better way is you draw it by your structure, because writing out in this way, you can draw it easily. So if you go like C7H16, you can't get the drawing you can't get the drawing out easily. So I do like this is because you can imagine this like a Lego. Okay, you plug and play. You plug out OH, plug out H, combine water, the rest you connect. Okay. So technically you can call it C7H16O2, but then no point. Like that better. Like that you can see the whole structure of the ester. Okay, guys, moving on. Okay, this is actually called a fractional distillation tower, where we can actually we put in petroleum, because petroleum got different mixture inside, got a lot of things inside. So we actually use this fractional distillation tower to separate your mixtures with different boiling point. Okay. So that's why usually the temperature at the bottom is higher one. So I put petroleum in. So petroleum, whatever boil, will move upwards. Okay, whatever don't boil will go downward. So any chemical that boils go upwards. Every stage we have different temperature. So whoever cool down at that stage, it will come out as liquid. So you see, lubricating oil cool down first, then the rest go up. Then at this level, diesel cool down. Then go up, kerosene cool down. Go up again, naphtha cool down. Go up, petrol cool down, and then leftover is petroleum gas that don't cool down because he got very low boiling point. So this is by using different boiling point, we separate your petroleum. Okay. So again, what is meant by hydrocarbon? I actually mentioned this in previous question. Hydrocarbon means only got hydrogen and carbon. Okay. So why petroleum can be separated using fractional distillation? I just mentioned because of different boiling point. And name X. Where's X? Name component X. Do you guys see component X? Am I seeing something wrong? No X, right? No X, last line. Go away. Is there any printing error? No X, right? What the shit? Did they mention anything about... No, X is in the question, is it? It's a mixture of hydrocarbon. The question, name... Teacher, your question got problem. Is it? Mana dia? Name component X. Yeah lah, I know X is here. But then there's no labeling X or anyway I see X. Okay, according to my answer, okay, let me see. The answer say component X is bitumen. Just now who actually went for Yutian's class? Did Yutian do this question? Because I think Yutian did this question, is it? Just now someone say page number 33 ma. Got ah. Kevin got ah. X is bitumen ah. He got say what's the problem here? Where you got X? Correction tape sendiri. Huh? Okay. So, okay, never mind. We answer the first few first. Oh, there's no X here. You want me to find my X, man? She's not here, man. Okay, sorry. Okay, what is meant by hydrocarbon? So we say that hydrocarbon is compound that contain carbon and hydrogen atom only. Okay, and why can we separate them with fractional distillation? Because we know that petroleum is a mixture of different size hydrocarbon that can be separated due to separated according to different boiling point. The X supposed to be bitumen. Yeah. I see the answer says bitumen, but the question never say where is X. Unless they say they correction take this, then they say this is X. That only makes sense, ma. Let's say name X. So then we say it's bitumen. But now they never tell me what's X. Okay, guys. You correction tape already. Okay, come. Correction tape. X. Because the question got mistake. Okay, not I want to do this, guys. Okay, what is component X? So component X is bitumen. So easy. Okay, guys, a big mistake here. Okay. Forgive Yutian. Okay, now we're having a flow chart. Okay, actually carbon compound like to ask flow chart also lah. So what flow chart we have here? We have alcohol P, add porcelain chip, become compound Q, and then can become compound R, then combine them, become not combine them, some combustion reaction, become carbon dioxide and water. The reaction 3 is P become S add calcium carbonate, become colorless gas. So many things here. Yeah. Identify P and Q. Draw the structural formula for P and compound Q. Name reaction 2 and 3. Write the equation. 8 marks. Okay, so guys, what is P and Q? What do you think is okay? Because they say already, alcohol P is alcohol. Okay, then technically your compound Q is after adding porcelain chip to your alcohol, then it will turn into compound Q. Correct? So at here, they say it's a conversion of ethene to few other compound. So guys, they give you one hint, which is ethene. Okay, yes, correct. Someone gave me answer already. You know why? First of all, do you see alcohol plus porcelain chip? What do you turn into if you put alcohol and porcelain chip together? What's the process name called actually? Porcelain chip is for what? Porcelain chip is actually to absorb water. So yes, we call this dehydration. So if you take out water from alcohol, it's left with compound Q. And what's compound Q? So if you don't recall, it's at here. Yeah. Do you see we can actually have no. Okay, see, your alcohol can actually undergo dehydration by adding hot porcelain chip. You turn into alkene. You see that? Alcohol become alkene. So let's say from here, again, we know this is ethene. Because the question say this is ethene, so we say this is ethene. Okay, so this is ethene. Okay. So guys, since we know this is ethene, what you think is P? P is supposed to be what? Ethanol, correct. Okay, can so chips what mean chips? Eternal time. Okay, and then what is porcelain? Porcelain is actually the full name is actually called alumina, or we could call it aluminium oxide. That's actually porcelain chip. Okay, porcelain chip is the common one, but the name is called aluminium oxide. Okay, so back to here. Then, what you think is actually happening? Oh my iPad again. It's a catalyst. It's a it's an agent that absorb water. Okay, agent that absorb water. Something like you know, the anhydrous calcium chloride, something like that. Similar thing. That's how you can absorb water away. You can take water out from alcohol, then you make it into alkene, ethene. Okay. R is oxygen. Okay, why R is oxygen? R is not oxygen. Because I see R is Q, do something to it, then become R. Then you see Q and R can both do combustion. Guys, we know ethene can do combustion. What is the other thing that we also do combustion? Correct, it's your alkane. So it's ethane. Okay, so when they do complete combustion, they'll get carbon dioxide gas and water. Okay, can and then Kevin, just now Yu Tian got do this question. I mean this one, the PQR. Got so did he actually get the same answer with this? Because I see his answer, I think it's wrong. I see his answer is wrong. Because he add porcelain chip. Because I see his answer, he say P is ethane 1,2-diol, Q is ethanoic acid. This is wrong. Did he give you the answer directly like that? So he said this is ethane 1,2-diol. And then he said this is ethanoic acid. He give you this as your answer. No one questioned him just now, eh? Like, we don't burn carboxylic acid and 300 people just now, no one realized this is wrong answer. Oh no! No people realize it's wrong. Yes, you see, compound S is actually the next one. You see, alcohol can do reaction 3 and then become compound S, and then S add with calcium carbonate give you colorless gas. Guys, you see, what add with CO3 can give you colorless gas? Okay, first of all, guys, what colorless gas is this? if you've got CO3, most likely your colorless gas is supposed to be carbon dioxide. Oxygen. Teacher, now where is reaction 2? Okay, never mind lah. I think this is just put in reaction 3. Stress, sir. No, I just feel like the question is very misleading, and then even you got wrong answer. What is reaction 3? You see, I say it, you see CO3, you get CO2, Then you think backwards. What plus CaCO3 can give you CO2? So carbonate with what will give you carbon dioxide? If you remember, there are 2 ways for CO3 to get you CO2. Remember? Either way, either you heat CaCO3, you get CO2, or you add acid to CaCO3, you get CO2. So compound S must be acid. This one cannot run. This one no way to run. Compound S must be acid. Okay, because only acid plus CaCO3 only can get you CO2, colorless gas. Okay, so what is compound S? Where your alcohol can turn into an acid, right? By doing what? By doing oxidation. So when you do oxidation, you get ethanoic acid. I think you can sleeping that time. Hey, this is a very serious mistake. He literally just give you everything. Okay. He discussed this question halfway only. Oh, is it? Means like he didn't finish these 8 marks. Because they say name reaction 2, they didn't even label reaction 2. I think not his problem. I think the problem is this question. Just how you know his answer? Because he prepared a answer sheet for us. So I looking at his answer, is wrong. But I think this answer he just copy paste. So I think he just follow. And I think he also realized it's wrong. He never finished this question just now. I think of some mistake. So where's reaction 2? I also don't know. Guys, there's no reaction 2. Okay, guys. Now I know why you can skip already. Okay. Okay, next question. Okay, this one. So many problem in this question. His answer got problem, the question got problem. Okay. At the end of the day, it's not my problem. Come next one. Okay, guys. I think. What's reaction 3? Oh, reaction 3 is oxidation. Because alcohol to acid is oxidation. Okay. From what I see here, this is the normal way to do lah. But they never tell me what's reaction 2. They never even label the reaction 2. They never even label reaction 1. So I cannot do if the question is missing everything. Okay, so guys, this question I think got mistake lah. This is why he skipped. Okay, so this one. Okay, reaction 1 is dehydration. How you know? They never label reaction 1 also. Correct. Assume. See, you assume then cannot. I assume this question got problem. Come, let's okay, let's not stay here lah. We just move on . Okay, hopefully this question not related If related to GG. Okay, ethene, C2H4, and ethanol are fuels which can burn completely in oxygen to produce carbon dioxide and water. You're assigned to evaluate which compound is more suitable to be used to heat water in laboratory. So guys, which one do you think is better to actually heat in your laboratory? More soot, okay. Is it because of more soot, and does it actually give you more energy and stuff? This is actually not related to percentage of carbon. Okay, because this one is between 2 different categories already. One is alkene, one is alcohol. Okay, if you want to compare percentage of carbon, you're supposed to compare alkane and alkene. Okay, but then right now, if you know that your ethene and ethanol, they are totally two different groups. You can't really just compare in this way. You can't mention, you can still say who is more flammable, who is less flammable, but then we will not relate to percentage of carbon, okay? Because this one is actually different category lah. So what we can know is if we know that ethene, alkene, and alcohol, okay, which one is actually more flammable? Wait, my cat. Suddenly my cat is screaming at the door. Wait. Okay, sorry. Okay. Right now, if you go into here, okay, so as we actually know, alcohol is supposed to be more flammable, so why is it more flammable? So if you remember, alcohol actually have higher fuel value, higher flammability, and we can say it burns without soot. Okay, so actually, burning with soot is actually not very good. Okay, means if you get more soot, actually not very good. So from here we actually, because got flame before we. Okay, so if you say that if it's ethanol, okay, if you selected ethanol, your explanation will be higher fuel value. Okay, higher fuel value. Or you can say burn without soot, because technically soot is incomplete combustion. If you guys know, soot is what? Soot is carbon. Carbon means it doesn't have a complete combustion. It's incomplete combustion. So burning without soot is better and give you more efficiency. Okay, but sometimes we also can actually choose ethene. But if you put in if you choose ethene, you have to explain in a different way in a different reason. So if you choose ethene, maybe ethene also good. You know why? Because ethene is supposed to be a gas, and gas is higher rate of reaction. Okay, heat of combustion, something like that. Okay, so if you say you selected ethene, you can say that ethene gas is smaller size to have higher rate of reaction. Okay, also possible. So here, if I pick either one, I get 1 mark. No. The 2 mark is you pick one mark, you explain 1 mark. Means choose one, either one you choose with explanation, you still get 2 mark. No need to write both to get 2 mark. Write one, and with one explanation, you get 2 mark. So means this one, 2 mark, this one, 2 mark. But if you put both, you don't get 4 mark. Don't think too much. Okay, then moving on. Ethanol is widely used in alcoholic beverages. Consumption of alcoholic beverages weakens the brain function, which can cause a person to become drunk. Okay, drunk drivers can cause traffic accident or so many things here. Okay. So now, reaction tree has been widely used to detect the presence of alcohol. Oh, it suddenly got reaction tree. Oh, I think it is. Okay. Reaction tree is widely used to detect alcohol. Okay. So describe an experiment on how tree can use to detect the presence of alcohol. So what do we know about reaction tree? Reaction tree is when you take alcohol, you actually react with oxygen, it becomes carboxylic acid, right? So what do we do? What do we do? So if you think about reaction tree, ester, no, don't go until ester here. Here it's still in between alcohol and carboxylic acid. Okay, what's the question? This one. How we can use reaction tree to detect the presence of alcohol. We link chemistry to daily life. So how to do this? If you think about it, let's say if you drink a lot of alcohol, so your breath supposed to contain alcohol, right? Then what's supposed to be inside this device to detect alcohol? So we're supposed to put the oxidizing agent. Why? The manganese 7 or maybe the dichromate 6 also can. Why? Because if that chemical is there, then alcohol come in, alcohol with that chemical, what happens to have acidified with the oxidation, right? Then the chemical will change color. Then you see color change, you know got alcohol. Okay, so of course, it makes sense, right? Now you know lah. Okay, so you breathe out alcohol, then the device inside got the oxidizing agent. So when the agent and your alcohol react, it shows color change. Okay, so 6 marks here. Let's try to go into that. Okay, so number 1, we can say place. Okay, because they say describe a laboratory experiment. So actually no need to go inside here. If got fruity smell, you wouldn't get fruity smell because it's not even ester yet. It's not ester. It's just alcohol plus oxygen, you get carboxylic acid. So you don't have ester yet. Okay. So your diagram is supposed to be the oxidation setup. So oxidation setup, maybe you can refer to this. Guys, remember this? Yeah. Oxidation setup, we can refer to this. So you can place like the alcohol, place the oxidizing agent into a test tube, something like that. Okay, that you actually channel alcohol into it. So okay, you say place maybe the agent. Okay, place acidify potassium manganate 7 into a boiling tube. Okay, then you're gonna take your alcohol, drip it into the okay, what can we do is maybe we can just have a cotton wool, okay, a cotton wool that soak in alcohol, because alcohol is liquid ma. Okay, so we supposedly we can, the diagram suppose in my brain right now supposed to be like this, a boiling tube. Okay, here here is your KMnO4, the acidified potassium manganate 7, and then I can just put a wool here. Okay, and then you can actually okay, so you can actually just heat this, and then the oxygen gas will release, and then you will actually react, and then you will see color. Okay, so you just heat like that. So we can actually add a glass wool, soak with ethanol into the boiling tube. Okay, into the same boiling tube. So we can actually close the boiling tube with stopper. Okay, then we can heat the boiling tube gently. After you heat it, okay, so if you say potassium manganate 7, you will say like purple potassium manganate 7 turns colorless, shows the presence of ethanol. Hey, well, this question took me long enough because of the mistake. Okay, so guys, moving on. So this one just a simple description on how to actually test a drunk person, whether is he drunk? Okay, so now moving on to the next one, we have 2 tables. One is compound S, one is compound T. Okay, now we have saturated. It's for saturated, 4th member of the series. T is unsaturated, it's the 3rd member of the series. So what is meant by saturated? So guys, saturated means what? Saturated means only got one bond. Because this time you all told me unsaturated got double bond. Then saturated got single bond. Yay. So we can say hydrocarbon containing single bonds between carbon atoms. Okay, then suggest the name for S and T. So S is single bond, T is double bond. So single bond is alkene. Sorry, alkane. Double bond is alkene. Okay, but what's the fourth member of alkane? So first member is what? Methane. Second member, ethane. So fourth member of alkane. Yeah, correct. So you can say S is butane. But T is third member of alkene. So what's the third member of alkene? So it'll be propene. His answer put butene. Why his answer? Why he got so many mistakes in his answer? Never mind, but guys, propane is correct. Okay, now S and T can be used as fuel at home. Which fuel is less polluting to the environment? So guys, what's pollution? Pollution is supposed to be the carbon, the percentage of carbon, means the soot. If you get more black soot, means it pollutes the environment more lah. So the calculation of carbon, how to calculate? Just now we did one time already ma. Okay, so we say, what is butane? So we know S is butane, and butane is what formula, guys? C4H10. Then T is propene. So propene is C3H6. Okay, so some student might say, teacher, lesser carbon, lesser pollution. Okay, but don't just look at just the carbon. You must look at percentage of carbon. So how to calculate percentage of carbon? So 12 times 4, okay, 12 times 4 over C4H10 total. So 12 times 4 plus 10 times 100. So what you get? Same thing do for propene. C3 is 12 times 3 over 12 times 3 plus 6. Multiply 100. You guys calculate both for me. What do you get for the first one? For butane? 82.76 according to Dylan. How about the second one? Propene? Oh no, guys, I found a mistake. I was wondering something wrong is here. You know what mistake I made? Do you all realize the mistake? How I become Yu-Tian already, GG. Okay, guys, you know what's the mistake? If you see until here, I did something wrong. Anyone realize? Give a clue. Third member of its homologous series. I was so confident on this guy is propene. But guys, after thinking for few minutes, I realized I was wrong. Okay, you know why? Because this is alkene, right? Alkene, alkene have one carbon? Just now we say alkane is methane, and then ethane, propane, and then butane. Okay, correct. But alkene, do alkene have methane? The alkane have methane? No. No one carbon alkane one. So the first member is supposed to be ethene, then propene, then only butene. So that's why, guys. This one is fourth member, then is third member. Okay. Small mistake, you see, small mistake give you a lot of marks. You lose a lot of marks. Careless mistake, yes, definitely my mistake. So guys, okay, this one wrong is butene. Okay, means this one here supposed to be C4H8. Careless mistake, guys. So sorry about it. Okay, so if you do your calculation, someone just now give me the other answer. I don't know whether it's correct or not. 85.71. If you do on C4H8, this same answer or wrong? This one is who give me one? Lenny give me 85.71. Still same, or is it? Okay. Okay, then yes. Wow, means you get 1 mark loose here, but you still get marks for the calculation here. Nice. Okay. So guys, sorry for the mistake. Okay, moving on. We have a flow chart again. Hopefully this flow chart no problem. Okay, maybe I'm the problem. Okay, sure. State process one. Okay, got process one. Okay, got process one. Okay, then the homologous series of X, functional group of Y, named with the molecular formula of Z. So we have this thing here, guys, C2H4. Obviously, this is ethene. Okay, what we do this thing called hydration. Guys, what's hydration? Hydration means you add what? You add water. So if you add water is H and OH. So means if you add in, it's supposed to become alcohol. So X supposed to be C2H5OH, which is known as ethanol. Okay. Then you see process one, they never tell you anything. Y also never tell you anything. But you see, you can take X plus Y to form ester. So if X is alcohol, then what is Y? Y is supposed to be ethanoic acid, correct? Ethanoic acid is CH3COOH lah. That's how we know. And since these two is 2 carbon, so your esterification is supposed to be the ethyl ethanoate. Okay. So I think process 1 is basically alcohol to carboxylic acid. So what you do to make alcohol become carboxylic acid, you learned it just now by doing oxidation. So we know process 1. Okay, I know space here, but you all can go for next page. So process 1 is oxidation. Then homologous series for X. Okay, what is homologous series? The group of it. So we know just now X is ethanol. So the group of it is called alcohol. Functional group for Y. Y is carboxylic acid. What is the functional group for carboxylic acid? Will be carboxyl group. Carboxyl group. Then write the molecular formula for Z. So guys, what is Z? So it's ethyl ethanoate, but they want the molecular formula. So name and write the molecular formula. Okay, so we know that Z is supposed to be ethyl ethanoate. Okay, so the formula will be CH3COO C2H5. Why like that? Because we know that the ethanol is C2H5OH. Then the ethanoic acid is CH3COOH. So to combine them, I take out the OH, I take out the H. So this combines to this. So CH3COO C2H5. So means this one from here, this one from here. Okay, so the blue curve one, don't need to write. I just give you an idea how I get it so fast. Okay, so that's the 5 marks we have. Is this 5 marks? Name, formula. So 1, 2, 3, 4, 5. Okay. 5 marks. Can moving on. Okay, we have 2 bottles here containing colorless liquid. One is bottle A, one is called bottle B. So again, C2 and OH. Right? Guys, you see OH? Ethanol. Then again, C2, but now is COOH. Still it, but it's ethanoic acid. Okay, now using sodium bicarbonate powder. Guys, what is sodium bicarbonate? Something that you guys actually don't see it every day, right? But technically, sodium bicarbonate powder, it's a base. Okay, because something metal carbonate. Okay, so if you put base, okay, describe the test to tell the difference between the 2 liquids. State the observation, classify them into their respective homologous series, 8 marks. Okay, and then do you see a table provided? Okay, so what we can do from here, they want you to describe a test first. So it means you actually take sodium bicarbonate, throw into the 2 different chemicals here. Okay, so step 1, we can actually measure 2.0 cm³ of liquid from bottle A and B. We do A first now, and pour into a test tube. Secondly, we can add, okay, because it's a powder, add maybe 2 spatula, or maybe 1 spatula also can, of sodium bicarbonate powder. Into the same test tube. Number 3, shake the test tube. And record observation. Once you're done with this, repeat the whole thing with bottle B. Sentence number 4, repeat step 1 to 3 with liquid in bottle B. Okay, so because it's a base, right? So do you think A from here okay, so which one do you think got reaction? So since it's a base, so base usually got reaction and will produce carbon dioxide because it's a carbonate, just guys, just I mentioned it. Carbonate only produce carbon dioxide with the presence of what? After what you add? So just like I say, to form carbon dioxide from carbonate, 2 ways. Either you burn it, you heat it, or add acid into it. So here got acid now. God. So means B is supposed to give you colorless gas, but A nothing. So that's why I put a table here for a result. So you can see your reactant. This one is liquid from bottle A plus sodium bicarbonate. Then liquid from bottle B plus sodium bicarbonate. So your observation, first one, no visible change. But second one, you're supposed to see colorless gas bubbles form. And now finally classify them into their homologous series. So you can say liquid A is alcohol. Then we know liquid B is carboxylic acid. Guys, okay? Yeah, we are at the last question actually. After chemistry, you all can go bio. Have fun with bio, guys. Okay, last question, guys. We have a butene here. So this is a butene, 4 carbon with a double bond there. Draw the structural formula. Haven't done. Okay. You all do first. Guys, I beat rush. I go toilet. Hey guys, I'm back. Done. Okay, last question. Draw the structural formula for another 2 isomer. Guys, what is isomer? Before we start, what is the definition for isomer first? Just in case they ask. Isomer means compound with the same what? Same molecular formula, but different what? Different drawing. But we don't call it drawing. We call it different structural formula. Okay, so how to draw isomer, guys? I told you guys isomer, right? You can actually play along with 2 things. Play with the functional group and play with the number of carbons. Okay, so guys, first of all, do you have functional group here? There is one, which is a double bond. So can you move around? If I write same number of carbon, correct? No. Must be same molecular formula. Because if you just write same number of carbon, then your hydrogen can be different. No, cannot. Okay, you must write molecular formula. Okay, so as I mentioned, guys, this one, what can we do? We can actually move the double bond to the next gap. So if you move it to the next gap, what do we call it? They want the drawing and the naming. So draw 1 mark, name 1 mark. So if I draw it out, it will be like this. Double bond in the middle. Okay, so what do we call this? It's still butene, right? But guys, there's a very special thing to add in. Since we can move around our double bond, the double bond position must be stated. So now your double bond is located at which carbon? So if I count from the left-hand side, it'll be 1, 2, 3, 4. So it's located between carbon number 2 and carbon number 3. So therefore, I choose a smaller number. I'll call this boot 2 in. Okay? Is it okay if I move my double bond to the last gap? Do I get boot 1 in? Do I get boot 3 in? No. Because this is already boot 1 in, guys. By the way, this is boot 1 in. Okay, this one on the top is boot 1 in. So you don't get boot 3 in. Why? Because you can either count from left or right. Always choose the smaller number. So there's no boot 3 in. Because if you put it at this gap, it is still called boot 1 in. So therefore, what's the next thing to do? Is to actually rearrange your number of carbon. So since I have 4 in total right now, I take 1 out. I'll have left with 1, 2, 3. Okay, imagine I took this out. Okay, I take this carbon away. Now my last carbon, I slot it in the carbon except for the first and last. Means cannot put here, cannot put here. The only way you can put is in the center. Okay. So if you get this, you put in all the bonds. Every carbon got 4 bonds. So what do we name this? Okay, this is no longer a butene. This is only left with 3 carbon. We call this a propene. Okay, but this propene got a carbon that it's not together in the chain. We call it a tail. So what do we call a tail? With 1 carbon. So we call it a mid tail. So it's a methyl propene. And don't forget the position of the tail. It's carbon number 1, carbon number 2, carbon number 3. So it's 2-methyl propane because the methyl is located at carbon number 2 of propene. So it's 2-methyl propene. Okay, guys, anyone have a question for this? Okay, guys, if it's okay, moving on. Can we explain the second structure? You mean the naming or how to draw? Name, drawing, you know how to do? Both. Oh, okay. See, so isomer is you first play around with your functional group. Like just now, I got functional group at here. So I move it to the second one, is to the middle. But I can't move it to the third one because it is still called butyne. Okay. So isomer means you don't change the total number of C and total number of H, but you change the drawing. So this one is called isomer. So that's why after I move it to the center, you can't move this thing anymore. Because cannot go here, cannot go here. You already got these 2 answers. So I need to find something special out from these 2. So therefore, instead of moving the bond, I can actually reduce number of carbon. So from 4 carbon, I can take 1 out, like playing Lego. I pluck 1 C out. Now I left with 3 C. Okay. Then I pluck 1 C out. I cannot throw away because I still need to put it back. So put it back to where? Put it back to the center carbon. As long the carbon is not the first and the last. You cannot say, teacher, can I pluck it out and put here? Cannot. Because like this still in a continuous chain. Isomer means you have to pluck out and make it a special tail. Because in this way, it's not a continuous chain, because you see 1, 2, 3. Is the last carbon connected to the top carbon? No. So this is what I want. I want it to be disconnected from my chain. Okay. Can it be 1-methyl propene? I just mentioned. Can you put your C here? Cannot, because if you put your C here, it is still a butene. Do you see it's a continuous chain? If it's a continuous chain, it is still a chain. It is still a butene. Only if you put in the center, then only you don't call it you can actually disconnect from it. Okay, I want a tail that is disconnected from the continuous chain. Continuous chain means you can connect continuously. So this is like 1, 2, 3, 4. Is it continuously? If you put here, you can still 1, 2, 3, 4. Do you see it's still connected? But then this one is not connected. Do you see it's 1, 2, 3? But the 3 cannot go here. There's no connection between 3 and this carbon. So the methyl represents the branch. Yes, the methyl is the branch. And this tail is at carbon number 2 of the propene. So it's 2-methyl propene. There will be no 1-methyl propene, because if it's at 1, it wouldn't be a propene. You understand? Okay. So again, if you bring this carbon into your first carbon, you don't call this a propene. It's still a butene. Just like your arm. You can bend up, you can bend down. Is it still an arm? Yes. But if I pluck my arm out, put it here, it's not my arm anymore. Just kidding. So the point is, the branch, okay, the branch must be disconnected from the continuous chain. Okay, only you can call it a branch. Does anything change if you put the double bond in the front? Oh, yeah. If I put the double bond here, no changes. Why? Because if I put it left side, I can still count from left side 1, 2, 3. If I put it on the right side, I count from the right side 1, 2, 3. So it's always 1 as a smaller number. You can give it a try. So if you put it at the back, count from the both sides, choose a smaller number. So means if I draw like that, this is still carbon number 1, 2, 3. If I count it here, 1, 2, 3. Still, I still choose this, I still choose this. There's no prop 2 in. Dylan, I just said there is no prop 2 in. Because if I count from the right side, I choose 1. If I count from the left side, I still choose 1. Always choose the smaller number for the naming. There is no prop 2 in. That's why when you see my name, I never put prop 1 in. Because there is no prop 2 in. Okay, can like you see Butin, got boot 1 in, boot 2 in, because there is a possibility of your double bond at different position. Here, if you only got 3 carbon, left or right doesn't matter. Either you look either way, count from either way, they are all prop in. There is no prop 1 in, there is no prop 2 in. Okay, so the answer must be 2-methyl propene. If you put 2-methyl prop 1 in, wrong. Okay, must be 2-methyl propene. Okay, moving on. You're learning chemistry at Blackpink concert. You're all going Blackpink concert again. Wait, faster, let me finish. Okay, so compound X, reaction 1 become acid, reaction 3 become ethyl ethanoate, reaction 2 become ethene. Okay, so guys, what do you think is compound X? You see, I say reaction 1 become ethanoic acid, then reaction 2 become ethene. So yes, it's actually ethanol. Why? Because alcohol, I can oxidize, become acid. Alcohol, I can remove water, become alkene. So that's a common thing that we can form, okay, from the alcohol. So now we know it's alcohol. Okay, so what is reaction 1? I told you alcohol to acid is what? You oxidized it. So you can say oxidation. And how you remove, what you remove from alcohol to alkene? You remove water. So we call this dehydration. Okay, what do you do to take your acid, okay, to form ester? Acid plus what become ester? Acid plus alcohol become ester. So technically we call this esterification. Okay, they want the name of reaction 1, 2, 3. So I have the names already here, 3 marks. See the name, homologous series, molecular formula of compound X. Draw the apparatus setup for reaction 2. So let's look at the name first. So reaction 1 is oxidation. So reaction 2, guys, I'm writing very ugly. I want it to be faster. Is dehydration. And then reaction 3 is esterification. And next one will be name of X. Okay, X is ethanol. And then the homologous series is alcohol. And the formula is C2H5OH. We have been learning ethanol for the past few questions. I believe you all know C2H5OH. And the last 2 marks is supposed to be the drawing for reaction 2. So reaction 2 drawing is the hot porcelain strips on the dehydration. So the picture, let me see your notes going on. Okay, the picture of hot porcelain chip, do I have it? Seems like I don't have it. I only have the words. Okay, let me see any place called Google search. No. The normal notes actually got one. Let me see. Okay, so we are doing dehydration. Okay, so dehydration supposed to be something like this. Listen. Okay, guys, this will be the picture for dehydration. Okay, so you have a glass wool soaked with alcohol. Okay, and then you put your porcelain chip before it. You heat it, then you get your gas here. You get your ethene gas here. Draw lah, yeah, draw. But they want you to draw, then you draw lah. You want to draw? I also drawing, okay? Look at my drawing, so beautiful. Teacher got go Blackpink concert ma? No lah. If I still go, I still doing here. Sorry guys, I'm not a very K-pop person again, so I don't care. Drawing only 2 marks. Yes, drawing only 2 marks. Then don't draw lah. Okay, guys. After that, next one. Okay, next one is actually procedure writing about forming a chemical called ethyl ethanoate, has a fruity smell. So now you want to describe the esterification step. Okay, guys, this one is basically memorizing. Okay, how to form ester. Basically, take your alcohol, your carboxylic acid, put together, add some catalyst. What's a catalyst for esterification? So if you want it in your notes, okay, I believe esterification, it's concentrated H2SO4 and heat under reflux. Then you're supposed to form your ester. Okay, so guys, this one here, I don't want to do lah. Basically, it's steps to memorize. Okay, but I want to actually do the equation. So again, is ethyl ethanoate. So ethyl, C up, what up? Haven't done with dropping. Don't like that. So ethyl ethanoate supposed to be C. Okay, it's ethanol plus ethanoic acid, correct? So ethanol plus ethanoic acid, C2H5OH. But ethanoic acid is CH3COOH. And then take out H, take out OH, CH3COO, C2H5 with water. So technically this is your chemical equation for this question. Okay, so this one gives you 2 marks. And then the procedure gives you 6 marks. Okay, so guys, procedure, I'm going to skip it because you all can just get the answer. Okay, can let me just discuss the last question from here. Okay, Mr. Matiran, okay, plans to buy a new car, but he was confused that between petrol and diesel engine, he's not only facing this dilemma. Okay, he's not the only one who's facing this dilemma. It is the most common question asked by people who want to buy a new car after he learned that diesel is a hydrocarbon that has greater number of carbon, and then petrol. Okay, then Mr. Matiran chose to buy a car with diesel engine. In your opinion, did he make the right decision? So guys, he chose diesel over petrol. Okay, you want to end early, is it? Yes, guys, I want to end early. Okay, because all this is memorizing, I don't want to go through that. But this one can discuss. So choosing diesel over petrol, is it a correct or wrong decision? Guys, usually this kind of question, it's very subjective. Means if you say it's correct, then you have to explain why. If you say it's wrong, then you have to explain why. So you have both ways to go through. So guys, here, choosing diesel, is it good? Okay, of course, there are benefits of choosing diesel lah. So diesel is what? Since it has greater number of carbon, of course, it gives you more power, but it gives you more pollution. So that's the side effect of diesel lah. Petrol gives you less power, but also lesser pollution. So this is the thing that we talk about. Okay, then we can talk about cost. Diesel is cheaper, petrol is more expensive. Okay, that's actually the real life examples. So what we can say, if you actually agree with it, so you can say yes. Okay, did he make the right decision? You say yes. So this one give you 1 mark. But this 1 mark, you must explain, only can get 1 mark. You don't go and say, right, yes, and then teacher, you expect teacher give you 1 mark. No. You have to write yes, explain first. If okay, then teacher give you marks in package. Okay, writing yes alone, no marks. Okay, so you can say energy release or energy produced from diesel is higher compared to petrol because it contains more carbon per molecule. And then we can say diesel. So we talk about more benefit about diesel lah. Diesel is for Hilux. Okay, diesel for diesel engine. Because I believe you all commonly know that 4-wheel truck, yes, these are all diesel. Okay, but some normal car also got diesel. Like you all know CX-5? CX-5 Mazda. Mazda got petrol engine, got diesel engine. So it depends what you buy. Okay, some model they come out both engine. So see which one you want. But I would say bus, lorry, okay, all the heavy vehicles usually is all diesel. Okay, but normal car usually petrol, but can be also diesel. So this is the daily life example lah. Back to here, we can say diesel is cheaper than petrol. Okay, and because it's high efficiency, you can say diesel can travel longer distance. Doesn't diesel produce more soot? Yes, that's why our normal car, they built using petrol engine. Because petrol give you lesser pollution, lesser soot. So it's better for environment. But then the thing is, in like let's say for bus so heavy if bus use petrol not efficient, not correct to the ratio. So for heavy vehicles, we still actually use diesel. So diesel now in small amount. Okay, normal citizen, normal Honda City, whatever you see, your Toyota Vios, okay, all is petrol because they want to reduce pollution. But actually diesel is a better fuel. I mean, in terms of power. Teacher, why cannot use alcohol? No soot. Correct. If you use alcohol, your petrol will be very expensive. You pump 1 time of your alcohol, you will need to pay at least 5 times the price difference. Do you want that? So that's why actually F1 they use alcohol because better burning, better energy efficiency, better fuel value. Okay, but in real life, so expensive. Who can do that? Okay, teacher, are we allowed to write point form in exam? Actually, yes, but then I would not suggest it unless you don't have enough time. Okay. If you use alcohol as fuel, won't everyone get drunk? Alcohol pump into the car, not let you drink. Hello, the alcohol that they pump into the car cannot drink one, you know. Okay, teacher, when you drive F1, I don't have to drive F1 in order to know that F1 pump alcohol. Hello. Okay, so guys, this will be the understanding for diesel. Okay, so this will be the answer for 4 marks lah. 1 mark for the yes, 3 marks for the explanation. Ask you when you want to drive one. This is not about me want to drive or not. Where do you get to drive F1? No way. Okay, so guys, what if you choose, if you say it's wrong? What if you say that Mr. Petrol is wrong? Petrol is better. Then you have to say like this. No. No, 1 mark. Okay. No, because we can say that petrol is more flammable. This is the first thing, more flammable compared to diesel. And then we can say petrol produces lesser soot during combustion that leads to lesser pollution for environment. Teacher, this is a different answer. Yeah, this one, if you say he's wrong, then this will be the other answer. No need to write both, guys. No need to write both. I'm giving you both because just in case someone want to disagree with Mr. Material. Because not everyone prefer petrol, not everyone prefer diesel. So people have different opinions. So you have two different answers. Means saying yes is also correct, saying wrong also correct, but then you have to pair with the correct explanation. Okay, guys, so I am officially done with part 1. Okay, so I guess you guys not yet done with part 2, right? So you all can go for bio first, you can go for account first, okay, then only you can go back to your part 2 for chemistry. Okay, so guys, mix and match a bit. Petrol is more flammable. Yes, petrol more flammable because it's actually more volatile. Because petrol they can easily evaporate. So when they are in gas form, they can burn faster. So more flammable. Bio got class, mate? Not tomorrow, mate. I think it's tomorrow. Tomorrow. Okay. Then you all maybe want to do bio first, Don't know. Up to you guys. Or you want to do chemistry first? Up to you. Okay. So guys, if okay, I will call it a day. Okay. Officially done with 9-hour class. I did 3 hours yesterday, 3 hours on the morning, 3 hours, 2.5 here. Okay, almost 3 hours or so. So guys, all the best for your chemistry. I'll pray for you all. All 9 hours you guys are here. Thanks. Those who came for all my 9 hours. I appreciate the effort. Okay, good job. I hope you guys will score in exam. Okay, so guys, goodbye. Teacher, can I get the English class recording? Okay, because English class only Yutian. So I don't have the English class recording. So I will ask from Yutian. So if I can get it, I give you all. Then if you want to watch my recording for this, you just go YouTube. Okay. So not sure whether you answer my question, but yeah, I can write carbon and not carbon. Carbon and not carbon atom. What do you mean carbon and non-carbon atom? Both got carbon atom. Just got one got more, one got lesser. Teacher, why so fast? So fast what? So fast end. No more question already. Finish already, Part 2 you want to do yourself. Can I write carbon only? Carbon can. Without atom. Better to write just one word Teacher, can you go back to page number 27? 27. Okay. Lazy Why? What lazy? I tired Okay, guys. Bye-bye. I still be waiting here So let's see anyone got any question. I know tired, you tired. You. Teacher, can I have the soft copy of this note? You never get your hard copy? Legit Oh no. Jocelyn, come to me. I send you the soft copy. Sijian, I will miss you too. Remember after SPM, come back to me. Coco got job for you. Okay, bye-bye. She just sent a WhatsApp. Yeah, correct, Jocelyn, yes. Okay, bye-bye. Bye, guys.